Have you ever gazed up at the stars and wondered if humanity could one day live among them? It's a breathtaking thought, isn't it? Building cities on the moon or Mars. But turning this science fiction dream into a reality is one of the greatest engineering puzzles we've ever faced. Today, we're diving deep into the incredible challenges of establishing off-world colonies. First up, the journey itself. Getting to another planet is no small feat. We're talking about incredibly powerful rockets, capable of escaping Earth's gravity with massive payloads. But it's not just about raw power. These spacecraft have to be ultra-reliable, because once you're in the vast emptiness of space, there's no roadside assistance. We need propulsion systems that are not only powerful but also efficient for long-duration missions, possibly using new technologies like nuclear thermal or solar electric propulsion to cut down travel time and carry more supplies. And once our pioneers arrive, where do they live? They can't just pitch a tent. We need habitats that can protect them from extreme temperatures, radiation, and the vacuum of space. Think about it. On the moon, temperatures can swing from a scorching 120 degrees Celsius during the day to a bone-chilling minus 170 degrees at night. So these structures must have incredible insulation. Radiation is another silent, invisible threat. Without Earth's protective magnetic field and thick atmosphere, astronauts are exposed to dangerous cosmic rays and solar flares. So, habitats will likely need to be built with thick shielding or even underground and lunar lava tubes or Martian caves to use natural rock as a protective barrier. Engineers are exploring innovative materials, like composites mixed with water or even local regolith, the soil on the moon or Mars, to build these shelters. Using local resources, what we call in situ resource utilization, is key to making these colonies sustainable. Speaking of sustainability, let's talk about life support. How do you provide breathable air, clean water, and food for years on end, millions of miles from Earth? Shipping everything from our home planet is just not feasible in the long run. We need to create closed-loop systems that are almost perfectly efficient at recycling. This means technology that can capture every bit of moisture from breath, sweat, and urine and purify it back into drinking water. Air revitalization systems would scrub carbon dioxide from the air and generate fresh oxygen, possibly using algae or chemical processes. And what about food? Forget about grocery delivery. Off-world colonists will have to be farmers. But this isn't your typical farming. It's advanced hydroponics and aeroponics in controlled environments. They'll need to grow crops under artificial lighting, with precisely managed nutrients. Scientists are studying which plants are best suited for space agriculture. Things like lettuce, tomatoes and potatoes, and how to maximize their yield in a small enclosed space. Every gram of food produced on site is a gram we don't have to launch from Earth. Then there's the challenge of power. Everything we've talked about, from life support to rovers, needs a constant and reliable source of energy. Solar power is a great option, especially on the moon, where you can have long periods of continuous sunlight at the poles. But lunar nights last for 2 weeks, so massive energy storage solutions, like advanced batteries or fuel cells, are essential. On Mars, dust storms can block out the sun for weeks, making solar power less reliable. This is where compact nuclear reactors, like fission power systems, could be a game changer, providing a steady stream of energy regardless of the weather or time of day. Of course, a colony isn't just a collection of buildings. It's a place where people work and live. This means we need infrastructure. Roads for rovers to transport materials, communication networks to connect with Earth and with other colonists, and workshops for manufacturing and repairs. Remember, if a critical piece of equipment breaks, you can't just order a replacement part from Amazon. It could take months or even years to arrive. That's why 3D printing is so crucial. Colonists will need to be able to print their own tools, spare parts, and maybe even building components using local materials. This self-sufficiency is the bedrock of a true off-world settlement. And we can't forget the human element. The psychological and physical toll of living in such an isolated and hostile environment is immense. Engineers and designers have to create living spaces that are not just functional, but also comfortable and mentally stimulating. This means considering things like lighting that mimics Earth's day-night cycle, private quarters for personal space, and communal areas that foster a sense of community. Virtual reality could offer a way to escape the confines of the habitat and reconnect with nature back on Earth. Finally, there's gravity, or the lack of it. The Moon has only 1/6 of Earth's gravity, and Mars has about 1/3. Long-term exposure to reduced gravity can cause muscle atrophy and bone density loss. While exercise regimens can help, engineers are also exploring futuristic concepts like rotating habitats that use centrifugal force to create artificial gravity. Imagine a giant spinning torus where the force pushes you against the outer wall, simulating the feeling of gravity we're used to. It's a complex engineering feat, but it might be necessary for the long-term health of our spacefaring descendants. From the rockets that get us there to the farms that feed us, every single step of building an off-world colony is a monumental engineering challenge. It requires pushing the boundaries of material science, robotics, energy, and life support systems. It's a testament to human ingenuity and our unyielding drive to explore. The path to becoming a multiplanetary species is long and filled with obstacles. But with each problem we solve, we get one step closer to that future among the stars. What do you think is the biggest hurdle to overcome? Let me know in the comments below. Thanks for watching, and if you enjoyed this journey beyond Earth, don't forget to like and subscribe for more adventures into science and technology.